Pretty cool. Looks like everyone's loading up here.
Okay.
So those of us who grew up in the 60s, we remember Romper Room. Lady used to come on and look in a mirror and say, I see Benjamin, I see Bob, Buddy, Cassie, Chad, Chris. Well, we can actually see your names. It's pretty cool. So let's do a quick sound check. Can you guys hear me out there in FCIA land? Can you hear me out there? Raise your hand if you can hear me. Jay Prajapati, great to see your hand up. And can't wait to get to the Middle East again. Thank you. All kinds of other people here. Awesome, awesome. Looks like people can hear good. That's awesome. And let's see what else we got here. Good. Things are loading up. People still coming in. That's good. Perfect. Okay, somebody typed in, yes, they can hear us. That's a good thing too. Perfect. Let me get to the audience view and then off we'll go. Okay, so good morning from Chicago. Actually not in the city, but if I look out my window to the right, where you can see, or to your left, I guess that would be, if I stand up in my office, I can see the skyline of the city of Chicago. We're about 12 miles straight west of the city off of the Interstate 290. So if you get on Google Maps and look for our address, 4415 West Harrison, and then go further east, you can see a beautiful skyline of the city of Chicago. Why is that cool? Well, from my perspective, I'm thinking fire resistance. Why? Chicago, you know, the birthplace of fire resistance, high-rise buildings, if you will. Why? Because we had a small fire in 1871 that burned down about a third of the city. And ever since then, our fire department here has been quite diligent at keeping key things in fire resistance. They believe that the density of high-rise buildings and a lot of people in them calls for higher fire resistance ratings. Until the 2019 code came in, which is based on the 18 IBC, we had 4-hour columns and 3-hour floors in high-rise buildings. They've dropped that down to 3 and 2, but they kept several other pieces like fire-rated corridors in schools due to the Our Lady of the Angels fire in 1958. So enough about Chicago. Rich Walke is going to join me today. He's in Hawthorne Woods, which is north and west of me by about 30 miles. And we're going to tag team like we usually do. We're going to take the proper design, installation, inspection, and maintaining protection. We're going to flip it upside down and start from the M, go kind of backwards and inside out, which will make for a fun program today. My name is Bill McHugh, Executive Director of the Firestop Contractors International Association. And we're always glad to do these webinars. First things first, I always ask when we start a meeting, a conference, anything, where are the fire exits? Even though we're doing this virtual, we should be asking the same thing. This building that we sit in here in Hillside, Illinois is 5 stories high from one part of the building and 6 stories high from another part. The lowest occupied floor is not quite 75 feet above lowest fire department access, so that makes it not quite a high-rise building, but it's huge. So I know where I'm going, out the door to the right, down the stairs, and then I'm going to walk down to the coffee shop and have a donut and coffee, Krispy Kreme right there. So know where your fire exits are, even if you're home, jump out of the window if you have to, hopefully not too high. Keep your hands off the keyboards, keep your ears peeled, because we're going to cover all kinds of good things in fire resistance that you don't normally hear from other places. A big thanks to the FCIA members that make these possible. You know, without the Firestop contractors, the manufacturers, the consultants, the distributors, the reps, and the friends of the FCIA, we can't do these. Because it costs money to run an office, to have cool people like Rich Walke with us, and we can't do it without your support. If you're a member, thanks. If you're not a member, we'd love to have you join, whichever category that you are in. We've got a category for just about everyone. Friends is probably the least expensive. For AHJs, authorities having jurisdiction, retired folks, that kind of thing. We're up for a free PDF of our manual of practice and a Word document specification as well. and have all kinds of resources available for free on our website. But that specification also comes in French for our friends up north in Canada. At some point, we will be translating it into other languages. But first, we have to get a few things done with the book. We're always doing something with it. Rich helped us push the standards chapter over the top. A huge update on that. It's now like 141 pages discussing the test standards in fire resistance, not just fire stopping, but all of them. The fire rated wall, floor, doors, dampers, fire rated glazing, fire stopping, everything. So a big thanks to Rich, as well as our team here at the FCIA. Kathy helped us administer and make sure we were on task, and Lindsay makes sure to promote it everywhere we go. So a big thank you to those folks as well. So if you want a free Life Safety Digest or magazine of effective compartmentation, email us here, info@fcia.org. We'll get it to you. And know that the FCIA has been in all kinds of different places. You'll hear about what we do and what we have done in the industry to try to advocate for better fire resistance rated assemblies through performance. Certainly testing is great, but after the products leave the warehouse, they have to be installed, inspected, and then the protection maintained that they provide after they've been installed. So what you're going to hear is pretty much an industry story about what the FCIA believed should happen for our industry. And we're also thinking forward because we've got some ideas for you to think about as you look at your organizations, whether they're design professionals, consultants, contractors, even the manufacturing crowd, whatever you're looking at, we've got some ideas for you too. We've got some conferences coming up. The FCIA's Firestop Industry Conference is in San Diego, November 2 to 5. We're going to do that hybrid, so you'll be able to watch it virtually, sign up for it virtually if you want, certainly for a fee because we've got to cover the cost of the AV, which is not cheap, and then also have face-to-face live people in it too. Our webinars and symposiums take place. Those are usually free. The barrier management symposiums we did with the American Society for Healthcare Engineers, those keep on cranking. They live in perpetuity at the FCIA website. There's a link to get over to the ASHI site. Just click on the barrier management link at the FCIA.org. Our code development process just finished up its committee hearings. We got the public comment hearings coming up here in October out in Pittsburgh. Rich and I and a whole host of others will be there to discuss some of the key changes that are coming for fire resistance in the building code environment. I can tell you nothing hugely earth-shattering that affects the industry in a big way, but some really awesome discussions took place during it, and some new things are going to get into the code too. Rich worked together with the ICC to find a way to reference the new head of wall standard, in other words, non-rated roof to a rated wall assembly, and have that referenced in the code. It's not mandated, but it's referenced, which is a good thing, amongst a whole bunch of other stuff. Our international discussions continue, and our growth internationally continues with our friends in Dubai, Doha, Riyadh, in Kuwait, in Oman, in India, in Australia, in New Zealand, the UK, Poland, Mexico, and many parts of South America. It's really, really cool to see that the FCIA, the international piece, is still growing. It was a long discussion when the association was forming, whether to put that international in or not. And we decided to put it in and not be like your typical American association that doesn't do anything internationally, maybe goes to, doesn't do anything. We decided to do things. That's why you see what you have. And check out this new thing, the education program, the level 1, about to launch the level 2 education programs, the Firestop Certificate of Achievement education program. The level 1 is really cool. I mean, Rich Walke and I spent 2 hours, we spent a lot of time, but we presented for 2 hours about the Firestop industry in great detail. You want more detail? We've recorded several webinars on all the different pieces of the standards, L ratings, M ratings, exposure, all kinds of stuff. Our education programs continue to get better and better, and this new certificate is something you can use to prove your competency because it's got an exam after it that you can use to prove to an authority having jurisdiction, a general contractor, a future employer, whatever you want to do, that you've got a certain level of knowledge in the Firestop industry. Just wait for that level 2. It's going to blow your mind about how good it is. So a big thanks to all the members, and let's get on with the show. So the DIIM, what is it? Just going to spend a second. It's proper design. Specifications are part of that design. Good specs. We worked with the Construction Specifications Canada, Construction Specifications Institute, Master Spec, SpecLink, and other specification agencies to make sure that the specification reflects what's in the building code and then communicates to you, the contractor, in other words, the Firestop contractor, through the general contractor and through the construction documents, communicates the right requirements for fire stopping and has some statements about the qualification of both the Firestop contractor and the Firestop inspection agency. We work at the building code arena to make sure that the codes reflect what the needs are in the field. Same thing with the ASTM and UL standards technical panels. We try to work together with our testing lab partners to make sure we bring the field perspective to the testing and the product development as well. But we really leave the inventing to the manufacturers. I mean, those guys, we have take our hats off to them all the time because they are some innovators. You know, they come up with these brand new products that try to help improve productivity, improve reliability of the installed system, and much, much more. Big thanks to the manufacturers for all you do. And also the distributors, and of course the contractors and consultants. When it comes to installation, one of the big things that we talked about when forming the association was, how do we find a way to set those companies apart that believe in the Firestop installation protocol, that the listing, the tested and listed system has to be selected properly in order for the whole assembly to work, rather than looking at it from a product material perspective. How do we find a way to get people to look at it from a systems perspective? That's where the FM 4991 standard for the approval of Firestop came from. Firestop contractors came from. That's where the UL qualified contractor program, ULC qualified contractor program came from. These are audit proven processes that are proven through audit that prove that the company knows what they're doing, basically. And we're glad to partner with those two fine organizations. The inspection standards, question at a conference. How come we don't have inspection like they do in fireproofing? Mike Pfeiffer, Vice President of Code, said to us, well, just have you got a standard? No. Have you gone to the code bodies to try to put it in? No. Okay, well, there's your strategy. Hop in it and build yourself a standard. So that's exactly what we did. So the 2174, 2393 standards, FCIA paid a consultant to build the first ones. And then we chaired it, have chaired it most of the lifetime of these standards from 2001. I currently chair the two standards task groups at ASTM. IAS, International Accreditation Services, accreditation for the inspection agencies. It's a big deal. And it's something that's going to grow more and more for the fire stopping. California and New York City have both mandated that IAS AC291 accredited companies be those that do inspection in those areas where special inspection is invoked. A big deal. And then maintaining protection, which is what we're going to start with today. So the DIIM, it goes in a circle. I've had this circle slide for probably 15 to 18 years, and I think it's great. Why? Because it comes from the quality management process thinking. Quality management process, it really evolved from a guy named W. Edwards Deming, a management consultant from just after World War II, who said to focus on the process rather than the people. If something's not being built right, don't go beat the people up. Check the process first to see if the process is set up so that the people can win. And if there are still problems with the people, train them to fix the problems that currently exist in that process. Deming is who came up with that program. And you know, each one of these pieces has been, if you look at it, DII and then barrier management, customized to our industry, your industry, our industry. Specifications, codes, standards, management system programs for contractors. The manufacturers have their own management systems, education, inspection in Chapter 17 of the International Building Code, Nfpa 80, Nfpa 1, barrier management. I mean, there's all kinds of things that we've customized to make this quality management circle work. So at the end of the day, the Firestop materials that have been installed to the manufacturer's installation instructions and the listings work as called upon by fire. I'm not going to get into these test standards because Rich is going to cover those in detail in a little bit. But just know the test standards that sit here are what define our industry. And what our industry has done that's different than other industries is we've put some standards around the installation and the inspection. When I say other industries, I'm talking about the compartmentation, fire resistance industries. Certainly there are some other industries that have some pretty good qualification programs for the contractors, lightning protection, sprinkler systems, alarm systems, but not much in the fire resistance area as well. So Rich is going to cover these things, mainly the testing for fire stops in a big way a little bit later on. So let's flip this program upside down a little bit, and I'm going to take us to the end of the program and work our way backwards and then come back forward and talk about the end of things. End meaning when the building has been already built and it's there, it's constructed, the building codes have been followed, the Astm E814 inspection found the fire stopping to be excellent. Then the building is turned over to the building owner and manager. And then what happens? Well, we all know what happens. Changes are made above the ceilings where the fire barriers, smoke barriers, firewalls might exist, or even where the smoke partitions are when there's no ceiling that's in place that would allow the building owner to not continue the walls up to the ceiling assembly, floor ceiling assembly above. That means changes take place all the time. How do we keep track of all the changes that take place in a building when really the building owner is focused on how's the carpet look, are the glass, is the windows clean, the lawn mowed, does the roof leak, is the parking lot got holes in it, does the sprinkler system work because the fire marshal's all over me, does the alarm system work because again the fire marshal that comes around yearly is going to ask me about it. What about the compartmentation? And everyone goes, huh, really, compartmentation? That's like totally forgotten. If you do some Googling, I'll say searching the World Wide Web, because Google is a company, we don't want to call it like Kleenex, but if you do some searching in the World Wide Web, you'll see when you enter effective compartmentation, you'll see various terms for it. I saw in a British publication, it called the silent policeman. Like, that really fits, silent policeman. Silent policeman that everybody forgot about. No problems have happened, so therefore we don't need this stuff. I don't think so. If you think about it, even in occupancies like I'm sitting in here, which is a business occupancy, I can tell you the way we look at the risk in our office versus our next door neighbor, totally different. I can walk by their office and smell, wow, what's that? Are there candles on? Sure enough, I'll call the building engineer, come upstairs, they put out the candles. I'm like, really? Candles? So in my opinion, some of these occupancies that the code thinks is the same, so therefore the risk is such that we don't need a fire resistance rated assembly to separate these two occupancies because they're the same class of business. To me, it's a bit nuts because I'm not a hoarder. Guy next door might be, the lady next door might be, and they might have risks that we don't. We all have microwave ovens. They're quite reliable these days, but you know, every once in a while, if somebody forgets it, turns it on for an hour, and it sits there with nothing on it, guess what? It's going to catch fire. Will somebody put it out? Maybe, maybe not. Enough about that. Let's talk about taking care of the fire resistance that's already in a building. My role here is to call it train you, not train, but provide you tools to talk to your existing building owner friends about maintaining protection of their fire resistance and smoke resistant assemblies. And I go through this stuff relatively quickly, but I really want to spend time talking about your role in protecting buildings for the life cycle. It seems the industries all talk about new construction, selling products, getting contracts, inspecting to make sure it's done right in new construction. The existing buildings, though, are probably a bigger risk right now than the buildings that are being constructed. You know, the codes over the last 35, 40 years have done a good job of updating, getting fire stopping right, all that kind of stuff. But, you know, what happens when that building gets turned over? What happened when the building was built in 1970 and maybe at the head of wall has only fiberglass insulation, mineral wool, something of that nature that was approved at the time? Does the building owner know that that might not provide continuous fire resistance and could cause fire spread? Do they know? Do they know that the fire and existing building codes have existed for decades and they're quite strong about maintaining protection? Do you know who it is that you should be talking to at these buildings to make sure that there's an opportunity to take care of them? If you're a contractor, Firestop contractor, maybe your base of business was pipe covering before it, or maybe it was building insulation, or maybe it's waterproofing and sealants. Regardless, some of your other divisions might have some great relationships with building owners and managers. And I can tell you that the building owners and managers probably don't know that they need your services as a Firestop specialist contractor or barrier management services contractor. So it's a little bit of a different discussion with a building owner that doesn't know. But I think if you show them some of the things that exist in the building, or in the fire codes, you might find a way to have them drop into their budget some money for taking care of their existing buildings. Why am I talking about this? Because if fires occur in older buildings that don't have protection, maybe the buildings were built in 1988 when fire stopping was part of the building code, but it wasn't done properly, or there were many, many holes put in those fire resistance rated assemblies that were never protected. If there's spread of fire and the sprinkler system didn't catch it, the fire forensics people can come in and say, you know, a fast spread of fire was caused by open penetrations or improper penetrations. The last thing our industry needs is that. What our industry needs is this fire was contained because the fire stopping and the fire resistance rated glazing, the dampers and the doors were all proper and did it right. They contained the fire. That's what we need to have happen. So we need each one of you to look at what you do in buildings and figure a way to convince the building owner or manager that they ought to have a maintaining protection budget line item to take care of their buildings. We're just going to cover the testing a little bit. It's complex, and you need to talk to the building owner about how complex it might be. But just know, if you're a building owner or manager on the call or on this webinar, here's the requirements in the fire code that require maintaining protection. And it's in many, many places. I'm just going to focus on 3, NFPA 101, NFPA 1, and the International Fire Code. These are North American standards and codes, and you'll find them in South America used. You'll find them in Mexico. You'll find them in Canada. Certain provinces in Canada use NFPA 101. Certain states in Mexico and areas in Mexico use pieces of the International Building Code, Fire Code, Energy Code, and NFPA 1 might be used in various places too. Here's what it says in NFPA 101 about maintaining protection. Calls out right here, fire resistive construction, continuously maintained. Why do I bring this up? Let me get through the rest of it. I'll tell you why after a bit. You know, litigious societies exist. The US has plenty of lawyers. We graduate lots of them all the time. Canada is a little more selective, but you've got attorneys everywhere. And you've got liability, but more importantly, the way word travels today, bad news that is, through the internet, through Twitter, through Facebook, through Instagram, through, you know, pick any of them, TikTok, whatever. The way things fly around the internet today, it takes a minute for bad news to travel. And we don't want bad news to travel about effective compartmentation. We want the good news to travel, that the silent policeman did its job and the fire didn't spread. So moving on, look at NFPA 101, it says in 46125, this is the general section. So the occupancy chapters would have to adopt this in order for it to be mandated as part of NFPA 101. But you know, from a legal perspective and from the press perspective. You know, if somebody loss of life, loss of property, they're looking at, look, well, you know, what kind of regulations are there? It's very clear right here in the codes what the regulations are for maintaining protection of existing buildings with fire resistance in it. Even says that the person that looks at it's got to be responsible, ensures the testing, inspection, and maintenance takes place at a certain intervals. And Nfpa 1 comes out loudly and says fire resistant construction shall be maintained and then properly repaired, restored, replaced where damaged, altered, breached, penetrated, removed, or improperly installed. I spoke through it fast, but you're going to see it again because this comes up in one other document, the International Fire Code, almost the exact same language. This is really amazing stuff here. From our perspective, we would like our membership, contractors, consultants, manufacturers, to show this to their building owner clients because it's a risk that they might not know about. And that risk is pretty personal because unlike a roof leak, which doesn't really kill people, fire spread, smoke spread could. That's why it's so important that we look at this and think about how companies like yours as a Firestop contractor, consultant, architectural design agency, engineering firm, how your firm can provide value to your customers that might be already using you for other things by focusing not just on fire stopping, but everything, fire resistive requirements. That includes fire dampers, fire doors, fire dampers, fire stopping, the fire rated wall assembly, and take a look, even the roof assembly. Why is the roof covering mentioned? That fire in Chicago, 1871, lots of wood buildings, the wood catches fire, it becomes airborne, lighter than air as it's on fire, drops onto the next building from the top side and burns through. 3 fire tests, spread of flame, intermittent flame, and burning brand. The burning brand, 12-inch by 12-inch oak that's run in rows and column back and forth, set it on fire, drop it on for Class A. Class B and C are smaller, obviously, but the fire code, Nfpa 1, is screaming about taking care of that roof covering. How do the roof coverings get their Class A? Some of them rely on a coating, and if that coating wears off, where goes the fire rating? If it's the ballast that gets it, ballast meaning rock or pavers, and that wears away, what happens then? Do we have an opportunity for fire spread? So, you know, fire codes are pretty strong. They talk about how often Nfpa 1 says take a look at things every 3 years. So there's a trigger in here that you, the professional, can bring to your building owner friend and say, every 3 years you should be doing this. Whether they use their own personnel or a contractor isn't up to us, the FCIA. We just want to make sure it gets done so that the fire resistance is reliable and works when called upon by fire. Look at Nfpa 1 even more. It says that the person that's responsible, remember at Nfpa 101 we saw a responsible person. This one says the responsible person's got to have technical knowledge and expertise in fire resistance rated design and construction. How do you get it? The FCIA built the barrier management symposiums. We built our Firestop certificate of achievement and education program where you get a certificate for taking exams on fire stopping just for this purpose. So you can prove that you're a responsible person because you've passed exams. The UL Firestop exam, the FM Firestop exam also can do that, as well as many other exams that might be out there too, and education programs that might be out there. The International Fire Code screams just as loud. So, you know, we're talking about the M, the maintaining protection. The International Fire Code is about maintaining protection. That's the ICC family of codes. We just debated the 2024 version of that. The committee action hearings, final action hearings again in Pittsburgh sometime in October. We got some more discussions going on, not much going on right this moment. The big change came, and Rich was the chair of the task group that helped make this possible, is that the International Fire Code now is broken into sections so that it covers fire stopping, fire dampers, structural fire resistance, fire rated glazing, all in separate places, because each of them are separate disciplines. The NFPA codes don't do that yet. We'll have to see what happens with that as time evolves. So here's what the program looks like. It's 5 different areas to look at, and then of course smoke barriers, smoke partitions, maintaining protections important, and then take a look at this. Here's the language that was in Nfpa 1. Visually inspected by the owner, this time annually, and it's not just limited to high-rise assemblies or high-rise occupancies. That high-rise occupancy every 3 years is what you saw in Nfpa 1. High-rise is defined 75 feet above the lowest fire department access, 75-foot occupied floor, and for us, occupied roof above lowest fire department access. That occupied roof hopefully comes through for the 2024 code, not quite as clear as in the 2021 code. So properly repaired, restored, replaced where damaged, altered, breached, or penetrated. So if I were to look at this sentence though, it doesn't say that the repairs have to take place every year or every 3 years. It says that the repairs need to be handled as you go. In other words, as the maintaining or as new surfaces are run above ceilings, breaching smoke barriers, fire partitions, that the protection needs to be maintained. Or if somebody punches a hole in a fire resistance rated assembly that's visible, that's got to be fixed and repaired with a patch that's fire resistance rated as well. All amazing types of things here that need to be taken care of. It also says records shall be maintained so the building owner or manager can prove to the fire official they've done these things. And then there's one more term in here that we want to talk about, and that is that in the charging language, there's this concept called an inventory of all required fire resistance rated and smoke resistant construction. What's an inventory that needs to get maintained? Well, unless we know what we have to maintain, what are these things? We don't know what to do and what kind of a schedule to put at them. You saw that there's an annual visual inspection in the International Fire Code. The Nfpa 1 has 3-year review of the fire resistance rated assemblies and the construction and the roofs. So what that does is triggers the building owner and manager in their procedures to have a review of these assemblies that matches up to what the requirement is in the fire code, so that when the fire marshal walks in and says, show me your records that tell me you did your 3-year inspection or your annual visual inspection, that you've got that documentation. The inventory would be, okay, Mr. and Miss Fire Marshal, we have either a software program on this laptop or on our tablet or on our phone, and here are the fire resistance rated doors from, pick a manufacturer. Here's the listing that goes with it. The glazing is found in the fire resistance rated assemblies. We pulled this from the UL Product IQ, and we've got it permanently on file. Why? Because things change. Manufacturers don't delist things, but they might not pay for the follow-up service and might not be listed in the directory anymore. So, it's important the building owner and manager keep their own records of what they have so that they know they can prove to the fire official that these are fire resistance rated assemblies. But it's not just the fire official they should prove them to. The departments of public health, the Joint Commission, other regulators, and maybe the building owner and manager should take their insurance risk assessor, the person that does the actuarial work for the insurance company, and walk them around and say, excuse me, but we maintain our barriers. We'd like a discount on our insurance, or at least don't raise it, and use that as a negotiating chip to keep your rates at a reasonable number. So that inventory is the listing, tested and listed system. It's the manufacturer's installation instructions and safety data sheets, because there's chemistry in all of these products, and workers need to know what they are for the life cycle of the building, not just for when it's new construction. That, along with the life safety drawings, gets you the inventory of fire resistance that we mentioned here. That was something that was put into the 2018 version of the International Fire Code. It's in the 21 version. It's going to be in the 2024 version. So if you're a contractor, educate your building owner manager friends. If you're in the, if you have other divisions in waterproofing, insulation, fireproofing, and you've got relationships with the building owner and manager, talk to them about what I just went through with you. Use those slides. They're, take them through to the FCIA website and you can click on the slides and see it. Or if you want to, just turn on the recording because the members can get to the recordings and just let this program present to them. But just know that the international fire codes out there, Nfpa 1 and 101, all of them have been out for decades with maintaining protection required. That inventory has to be maintained, and we're trying to reduce the risk of fire spreading in buildings and increase the reliability of the installed systems so that we wind up being the success story in the press that we stopped fire from spreading from place to place. If you have experience with that and have seen where the fire stopping, the doors, the dampers have stopped fire, and you've got pictures, send them to us. We want to find a way to use our platforms from the FCIA to promote the effectiveness of effective compartmentation. Certainly we might have to talk to legal people, have to talk to the building owner, make sure that we can use these stories. But the more stories we can get from you, the better we can promote that out to the industry. Where there's fire resistance used, it's used most in hospitals, nursing homes, and prisons. That's where you find a lot of compartmentation, apartments, condominiums, universities, laboratories, warehousing, manufacturing. Those are the building types. Who do you call on to find these people? Hospitals, universities tend to call that person the physical plant manager. They manage all of the physical plant. The healthcare facility director, ASHE member, American Society for Healthcare Engineering, and all the local chapters. They have a big job. They keep track of a lot of stuff, including equipment that moves through that hospital as well. They have responsibility for that. You imagine how much they got to keep track of with their staffs as well. A lot to do there as well. So life safety drawings, the tested and listed systems, the manufacturer's instructions, keep track of them, either paper, spreadsheet, software, and think about becoming a barrier management services professional. The FCIA has a section, the barrier management services section, and that's where you get found. Those are the types of activities, inspecting fire doors. Nfpa 80 says do it every year. Annual visual inspection of fire doors. Do they open, close, and latch? Is the hardware still there? Did somebody put screws where they shouldn't be? Is there too many papers plastered all over the door? Fire-rated fire dampers. Have they been tested? Is it now using remote testing? Somebody still has to flip the switch to make sure that the damper opens and closes as it's supposed to when it's activated. And then also the visual inspection of the wall and the horizontal assembly for breaches in those assemblies. That has to be done. The building owner manager has to do it either annually or every 3 years. Whatever it is, somebody's got to do it and somebody's got to track it. If you're not in that business yet, think about getting trained, getting educated, and getting into it. The FCIA has resources to help you with all of the above. So let's go back to the beginning and get us a few slides before we turn them over to our friend Rich Walkie. This is where I was. I started with this one, which is a fire resistance rated wall. Somebody's put a label, or as we call them, an identification system on that assembly to show that it's a Firestop system. Don't remove the label, don't paint over it, and don't mess with the system because it's been installed for a good reason. And then Rich gave us this photo, or didn't give us this photo, but we took this photo. Rich and I have been using this for education, and we ask ourselves, which number is it? Is it CAJ 5138, 5209, 5091? Whatever it is, it's going to have requirements for the sleeves, for the depth and thickness of mineral wool, sometimes the direction and the orientation of the mineral wool, the type of sleeve, type of insulation, all of that's going to be in the tested and listed system. Before we get to the tested and listed system, though, Rich has to tell us about those tested and listed systems. I'll tell you, before Rich talks about that, I'll tell you that this is what gets put into the specifications. They talk about systems in part 1 of the specifications and the product properties of those products that are being used, that they match what the conditions are that are expected to occur in the field as well. Contractor requirements, I talked about those already. There's inspection requirements. The inspectors, we believe, should be educated and also pass the UL, the FM, or the IFC, and the IFC exam. because we believe those are important exams to pass. And then special inspection occurs. When it comes to the life cycle of the building, though, this Division 1 is hugely important. We did a program for the Construction Specifications Institute, CSI, CSC, Construction Specifications Canada, and I can tell you that the architects and specifiers had their note pens out and were writing or typing notes when we brought this slide up. In the audience when we presented this was Dennis Hall. Dennis Hall speaks at the FCIA conferences. He'll speak at one of ours here soon. And what he speaks about, or what he did was, he's the person that took the numbering system you see on the left, 6 digits, from 5 till 6. And he reorganized the master format. It was a big program. The book Moving My Cheese and all that kind of stuff took place during that same time. And our buddy Dennis moved everybody's cheese. So anyway, I asked, hey man, what about this 017839 project record documents? Is this where all the fire resistance has to be kept? So that the general contractor has a direction from the specification to provide all the systems, manufacturer's installation instructions back to the building owner and manager. Is this where this all takes place? And he said, yep. This is where the direction comes to the general contractor to gather tested and listed systems, manufacturer's installation instructions, safety data sheets, put them in a packet, hand them to the building owner and manager so they can maintain it. So after those presentations, we got phone calls and emails from the people at Master Spec and other master specification programs to help them with that section. And guess what? It refers not just back to 078400 fire stopping, it goes to fire dampers, fire doors, fire rate glazing, gypsum wallboard, concrete, and other places as well. A big deal. Building codes have requirements. There's terms for the fire rated assemblies. These are all tested to Astm E814, UL263. I'm not going to cover that today. If you want to hear about that, visit with us with one of our other webinars. Also know that even old assemblies have fire resistance ratings. You can go find where there's not documented systems, go find what the hourly ratings are in the back of the International Building Code up until about 2 cycles ago. Now you find it in the International Existing Building Code. HUD, Housing and Urban Development in the US, also has a document on archaic assemblies to figure out what the fire resistance rating is of this. But that's not the contractor's job to do. That's the fire protection engineer and the design professional to declare that the clay tile block, gypsum block, plaster, whatever it is 30 minutes, 60 minutes, 120 minutes, 240, whatever that is. As far as developing those fire ratings, tested and listed systems, calculated methods, prescriptive methods, and then of course using the resources on the books as well. Smoke barriers are critical. We've talked about L ratings. Rich and I have done a program on L ratings, I believe, already to talk about the development of it, how it works. Go look on the FCIA.org for the recording of that. It's well done and talks about L ratings in great detail. So let's talk about testing. And at this point, what I'm going to do is turn it over to Rich and let Rich drive the bus from here forward to cover the testing. You're like, Bill, you know, we've covered testing before, and yes, we have. But you know, every time you listen to this thing, you pick up something else as a new piece that you maybe not have caught the last time you listened to it. Knowing the testing helps you explain to the building owner why the maintaining protection has to be done a certain way. That you can't just go, oh yeah, we're going to put some wallboard compound and use that as glue for a patch inside a gypsum wallboard assembly. You can't do that because the hose stream test will blow the patch right through the assembly. It has to be a fire rated patch. The Gypsum Association in GA 225, their document explains how that fire rated patches has to be built. Then the manufacturers of gypsum wallboard have some proprietary testing that will give you other recipes for patching gypsum wallboard as well. So you need to know what the testing is and be able to explain it in order to be able to convince the building owner and manager why your method makes good sense. So Rich, I'm going to turn it over to you. I'll turn my camera off for a little while and my microphone off. and let you drive the bus and give them some detail on fire testing as well. If you venture into a little bit of walls and maybe throw some damper doors in just for fun, feel free.
Okay, great. Thank you, Bill. And good morning, good afternoon, or good evening to everyone. You should be seeing my screen, which now shows a heading Fire Stopping for Continuity, hopefully.
Yep, you're all good.
Okay, and I am not seeing that, so let me change this over, hopefully. There we go. Now I can see what I'm doing. Okay, so we're going to talk about the installation concept of the DIIM philosophy, and that really relates to the installation of tested and listed, or in other words, classified systems, tested and listed by some laboratory, UL, Intertech, Factory Mutual, whoever. So we'll talk a little bit about some of the standards. We'll talk about the testing processes involved in those standards or described by those standards, and ultimately conclude with where those systems are published and what do we do if we can't find a published system that meets our needs. So let's talk about the testing for now. And I always like to try to differentiate between the code definition of fire stopping versus the industry's definition of fire stopping. Kind of sets the stage for what we're talking about. By the code, the word fire stopping relates to the protection of penetrations. However, the industry has expanded the use of that phrase to include not only the protection of penetrations, but also protection of joint systems, perimeter fire containment systems, continuity head of wall systems. So we've got a little different terminology, so I always like to set that stage before we get going. So there's a whole host of standards which are used to evaluate fire stopping by the broader definition of that term. We have UL 1479 and Asdm E814 and FM 4990 that covers the testing of fire stop systems. We have UL 2079 and Asdm E1966, which covers the testing of joint systems. And then Asdm E2837, which covers the continuity head of wall joint systems. And good news, as Bill mentioned earlier, is that we were successful in getting that referenced in the 2024 International Building Code. So when we get to that point, we'll see that is now an option for protecting that void at the top of a fire barrier beneath a non-fire resistance rated roof assembly. And then we have Asdm E2307, which relates to the protection of the perimeter safing slot. Typically, protection system is referred to as a perimeter fire containment system. But now, going back to the more specific definition of a fire stop system based on the code, meaning the protection of penetrations, we really have 5 rating identifiers that are spelled out by the standard UL 1479. We have an F rating, a T rating, an L rating, a W rating, and an M rating. If we turn to the ASTM standard, Asdm E814, it includes only 2 of those, an F rating and a T rating. But from the perspective of the fire test procedure, the F and T rating, the UL standard, and the ASTM standard are considered equivalent. So let's look at then each of these individual ratings and determine what they really refer to. An F rating is typically referred to as a fire rating, and it relates to the ability of the system to prevent a passage of flame from the fire side to the unexposed side, and also for the system to be able to meet a structural integrity test, which is administered through the application of a water hose stream test to the exposed side of the test assembly after the fire exposure. So all systems are assigned an F rating. All systems are also assigned a T rating, and the T rating criteria includes the same 2 criteria of an F rating, passage of flame and successful hose stream performance, but it also adds a 3rd component. That 3rd component relates to a limitation on the temperature rise on the unexposed side of the assembly. That temperature limitation is a 325 Fahrenheit temperature rise. So really what we're trying to do is measure whether the system will keep the temperatures low enough that we won't be concerned about ignition of combustibles on an exposed site during a fire exposure. The third rating is the L rating, and that is an optional rating. It was added to UL 1479 around 1992, and it relates to the leakage rate through the Firestop system at both an ambient temperature and at a temperature of 400 degrees Fahrenheit. So it represents leakage of cold smoke and hot smoke. And the test is administered through leakage of air through the system, but in reality, we all know the realities where this test really relates to smoke leakage through the system in an actual building application. The fourth rating is a W rating, and this again is an optional rating. It was developed in 2005, and it relates to the ability of the Firestop system to prevent passage of water through the system. And the concept here is we're referring to incidental water exposure. What happens if we have an inadvertent sprinkler activation or perhaps a plumbing leak, a roof leak? Regardless of where the water comes from, we now have water on the Firestop system. Will the application of that water penetrate through the Firestop system to the floors below? And that test is administered through the application of a 3-foot water column onto the Firestop system for a time period of 72 hours. And during that 72-hour time period, there can be no leakage of water through the system whatsoever. But in my opinion, even more important than will that system prevent leakage of water is, will that system continue to perform its fire function after exposure to water? If we do have that plumbing leak, then the system is exposed to water, system is ultimately dried up. Will it continue to provide its fire performance as a result or after exposure to the water? To me, that's the bigger issue. So in terms of administering the W rating, the Firestop system is subjected to that water exposure first. It's dried, and then it's subjected to the fire and hose stream test where the F&T ratings are established. So systems that do have a W rating have demonstrated that they will continue to function after exposure to the water. Systems that have met that criteria are assigned a W rating. The last of the current ratings would be the M rating, or movement rating, of a Firestop system. And really what that relates to is the ability of the Firestop system to accommodate movement of the penetrating item relative to the barrier in which it's passing through. And in terms of the testing, the Firestop system, or I should say the penetrating item, is moved perpendicular and or in the plane of the barrier in accordance with a test procedure outlined in Asdm E2307. And then after that movement, the system is subjected to the fire and hose stream tests where the F&T ratings are established. So again, it's kind of a fitness for use test. Will the system maintain its F&T rating in spite of the fact of being moved during the life of the building? And systems that have been subjected to that optional M rating are assigned an M rating. The published rating will reference the percentage of movement relative to the annular space within the plane of the barrier, or it will relate to, or will specify the movement capabilities perpendicular to the plane of the barrier, based on some dimension, plus or minus a ½ inch, for example. So this slide somewhat exemplifies or shows what we're really referring to when I say within the plane of the barrier or perpendicular to the barrier. The dimension that's identified by the letter Y relates to movement within the plane of the barrier, and the dimension Z relates to the movement of the penetrating item perpendicular to that barrier. So each system with a M rating will specify the movement capabilities in those two dimensions. So let's now talk about how fire tests are conducted in accordance with either UL 1479 or Asdm E814. So this photo shows a test assembly sitting on top of the test furnace. In this case, the basic barrier is a concrete slab assembly. It looks like there are multiple, perhaps 5 or maybe even 6 individual non-metallic penetrating items that are penetrating through this one concrete slab. The system has been fire stopped already, and the thermocouples, which are being used to measure the temperature on the unexposed side of the assembly for compliance with that T rating requirement, have been installed. Those are the wires, I'll call them, that we see sitting on top of the assembly. And so after that construction and instrumentation, the assembly is placed on top of the furnace, and then it is subjected to a standard time temperature fire exposure from the underside of the assembly, and the temperature of that fire exposure reaches 1,000 degrees Fahrenheit in 5 minutes, 1,700 degrees Fahrenheit in 1 hour, and 2,000 degrees Fahrenheit after a 4-hour time period. And during that fire exposure, the furnace flue conditions are adjusted, so we always end up with a positive pressure within the furnace relative to the laboratory environment outside of the furnace. And the idea there is that higher pressure in a furnace will force flames and hot gases through any cracks or voids that might develop during the course of the fire testing. And during the fire exposure test, what the laboratory is looking for is whether there is any through projection or through passage, I should say, of fire from the fire side to the unexposed side of that assembly. Laboratory is also recording the temperatures on the unexposed side of the assembly for compliance with the T rating requirements of the standard. So after the completion of the rating period, which is something that's normally assigned by the manufacturer ahead of time based on their expectations on how the assembly will perform. So after that rating period, the assembly is pulled off the furnace and then subjected to a hose stream test. And the idea of the hose stream test, again, it's a structural integrity test to measure whether that system has sufficient structural integrity to stay in place during a very dynamic fire event. And it happens to be administered by a water hose stream, so hence the name hose stream test. And the idea is we subject the sample to a 30 psi pressure hose stream for a typical 1 through 3 hour rating period, or 45 psi hose stream for a 4-hour rating period. On the fire side of the assembly, we use slow, easy motions, horizontal, vertical motions to impact the assembly. And the concept is that the assembly, the Firestop system, needs to prevent any through projection of water during that hose stream test. The duration of the test is based on the size of the sample. For a typical 2 to 3 hour system, that rating or that duration is 1.5 seconds per square foot of test area. So for a typical 16 square foot horizontal assembly, that would be a 24-second hose stream exposure. So that's the currently published ratings that are established for Firestop systems, but certainly Firestop systems can be used for other purposes than just for, fire temperature, leakage, water, or movement. There are other ratings that are being talked about by the industry and someday will probably become part of the standard. Things like chemical hazards moving through the system or passing through the systems, biological hazards, radiation, germ passage, or explosion resistance. All of those are future ratings that could be established, and they're not yet there, but there are some manufacturers who do have some information on the performance of their systems to those sort of conditions. So if you have a need for that, check with the manufacturer, see if they've got anything that will help you out. And we'll all keep pushing to ultimately establish additional rating criteria for these hazards. So I talked about the expanded definition of fire stopping. Here's an example of one of those expansions. That would be the evaluation of the void at the edge of the floor slab, between the floor slab and the curtain wall. If left unprotected, fire has the ability to penetrate, pass through that slab to the floor above, negating the whole concept of fire resistive construction. And if you go back in time, that was one of the issues with the first interstate bank fire that occurred in, I believe it was 1988, followed shortly thereafter by the One Meridian Plaza fire in Philadelphia. likewise, that was one of the issues that void was unprotected. So we've learned from those fires. We now have Astm E2307, which does evaluate the ability of the system to prevent that interior spread of fire through that safing slot. Along the same lines, there is a second concern with the exterior curtain wall, and that would be something that's referred to as leapfrogging. Leapfrogging is where the windows in the fire floor break out, allows a flame plume to pass through those windows and potentially ignite the exterior curtain wall if it's combustible, or at least project past the spandrel section of that curtain wall, breaking out the vision glass up above, igniting the window treatments, and then ultimately, breaching the concept of fire-rated construction by allowing flame passage to the floor above. So there's a new standard that Tony Creamy spearheaded, published a couple years ago, Asdm E2874, which looks at whether the curtain wall will resist that concept of leapfrogging. So we tried to get that, or I shouldn't say we, Tony tried to get that into the 2024 building code, international building code, I should say. Unfortunately, that proposal was disapproved, but we will all keep trying, and hopefully at some point in the future we can upgrade the code to include criteria relating to leapfrog also. So once these systems are tested, they're published in the online directory of the testing laboratory. That could be, FM approvals through their approval guide, could be through Intertech through their online directory of building materials, or building products, I should say, or through the UL or ULC Product IQ online directory. All three of these directories include tested listed systems, tested to the standards that we've been talking about. So the next item I want to talk about are what's referred to as engineering judgments or equivalent fire resistance rated assemblies. Now, what are these? Well, really, they relate to situations where there is some unique field condition that exists where there are no tested listed systems available from any of the labs through any of the manufacturers. Now, what do you do? Now, those conditions could result in some very unique construction condition, which certainly is common out in the field, or unfortunately, sometimes a lack of planning on the part of usually some other trade, and they ultimately leave the fire stopping contractor, pulling his hair out in terms of how do we protect this unique situation that shouldn't have developed in the first place. But anyway, we address those through engineering judgments or equivalent fire resistance rated assemblies. And when we get to this situation where we've identified a need for an engineering judgment, what should we be doing? Well, it's a process. The first thing should be to look for another system. Hopefully, the same Firestop material manufacturer will have another system that covers the unique field application. If so, simply use that system. You're done. You're all good to go. If the original manufacturer doesn't have a system, perhaps look for a system from some other manufacturer. Again, a tested list of systems just with different fire stopping materials. If we can find one, again, you're good to go. Use that system. If not, now you're into that realm of an engineering judgment or equivalent fire resistance rated assembly. And those two terms really are I consider them more or less equivalent. Most of the industry uses the phrase engineering judgment. Factory Mutual prefers the phrase equivalent fire resistance rated assembly. But bottom line is, when you do need to get an engineering judgment or an equivalent fire resistance rated assembly, you do that through the use of engineering, through the use of tested data on systems that are similar to what you're looking to install. The International Firestop Council does have a protocol on how to use engineering judgments. It's a very well-written document that gives some good guidance for everyone involved, everyone from the code official to the contractor to the architect, in terms of how you do these engineering judgments. And again, it's based on science, it's based on engineering, it's not gut feel, I think this is going to work. It is science-based. So some of the highlights of the IFC engineering judgment guidelines would suggest that An engineering judgment is not a substitute for existing designs. If there is an existing design, use it first. It emphasizes the importance of tested designs. A tested design is always the starting point of an engineering judgment, and then you evaluate what modifications exist from that tested design to the unique field condition. The guidelines also suggest that the judgment should be issued only by those who know the performance of the components, which would be, you know, I suppose you use 4 parties that could be doing that. We could have a PE, an FPE, a testing laboratory, or the manufacturer issuing those judgments. My personal opinion would be the best home for those engineering judgments is really the manufacturer, who knows the performance of their products better than the manufacturers. Typically, the folks doing the judgments are the same folks who are setting up and witnessing the fire testing at UL or at their own facility. So they have a real good handle on the performance of those materials. Testing laboratories also do a great job, or others, you know, folks like myself who have years and years and years of experience of testing. You know, we know how those systems perform and can do a valid judgment. The weakness of using a PE or fire protection engineers, they may not have the test data of the original system you're comparing it to, and they also may not know Firestop systems the way that others might. So anyway, important point is you need to use somebody who has knowledge of those components. Engineering judgments need to be based on sound engineering practices and knowledge of the performance of the closest system. It should be based on interpolation as opposed to extrapolation. Should be issued only for the specific job site. So all engineering judgments should reference the particular job site. For example, the Willis Tower, Chicago, Illinois. And of course, it needs to be presented in clear detail. IFC doesn't dictate what that really means. Could be through use of CAD drawings, or it could be verbal. When I was writing Firestop systems, and when I continue to write Firestop systems today, I usually will reference the system that exists at such a location. It was essentially constructed in accordance with UL design or system number such and such, with the following exceptions. I outline the exceptions, then it's clear to the code official, clear to everyone involved, what criteria was the system evaluated to. So any case, so that completes my discussion on the installation side of things and the use of tested systems. So I will turn it over to Bill at this point and let him continue. Thank you. We'll take questions at the end of the program, of course.
Yeah, we'll hammer the questions later on. So a couple of them have come in, and again, if you do have questions, type them in, and we'll catch them when we're finished up. We got about 23 minutes left in the time allotted. Thanks, Rich, for taking some time to talk about engineering judgments, test standards. All are important, because why? The test standards, whether it's in the UL directory or in the FM approval guide, which you find over here under building materials, and then we go over to wall and floor penetration fire stops. Regardless of what it is, this is where you find the suitability for use statement of the products in the specific application, with all the limitations that might come with it. What's the inner space size? How many cables can go through here? How many pipes can go through here? This is what determines what a fire stop system actually is, whether it's at the FM approval guide, Intertech guide, or at the UL product IQ, whether it's continuity head-up wall systems, go through the assemblies here, fire doors and fire windows, the roofs, the walls, the floors, the beams, the columns, grease duct assemblies, exterior wall assemblies, electrical circuit integrity systems, fire stop systems, of course, which would be for penetrating items, penetrations and such, all with the numbering system that we're all familiar with. We'll cover that in greater detail at future FCIA webinars. Today's program is not to do system selection. We do that in another webinar, but it's really to give an appreciation for what constitutes a fire stop system. I'll just take a second. We'll try to get to a system. I think we had C-AJ-5091, I think the number was, that we had showed earlier. And it's going to show a, whether, doesn't matter the manufacturer, specified technologies, Hilti, 3M, Rector Seal. All of them are great manufacturers, and all of them have their own unique Firestop systems. It might look like this. They might not look like this. Just know that they all compete with each other. So they're going to have systems that are similar, but they'll all have some kind of a difference to them. The materials can't be swapped one for the other. Once you have a CAJ 5091, you're locked into using whoever the manufacturer was. In this case, it was a Hilti Firestop sealant in this particular application. Key things like understanding whether or not the sleeve can be flush with the floor or extend a maximum of 3 inches above the floor. When Rich was talking about engineering judgments, maybe the contractor installed a system that looked just like this, but it installed the Firestop product at the top of the sleeve. So the question would be, where does the Firestop sealant get installed? That's all down here, flush with the top surface of the floor or both surfaces of the wall. So guess what? If somebody installed that Firestop sealant at the top of that sleeve, we got a problem. And the problem is the system shows it at the flush with the wall or the floor, not at the top of the sleeve. You're like, really, Bill? Is the Firestopping that picky? Yes, it is. Now, mind you, Hilti or one of the other manufacturers probably have another system that shows the sealant at the top of the sleeve, but for this particular system, it doesn't show that, so it wouldn't be able to use it. That concept flows throughout our Firestop industry, whether it's joints, perimeter fire containment. All of these assemblies are very specific in the construction that's assembled here. The sleeve has to be as in the field as it's shown in the lab design. The thickness of insulation, the type of insulation, the type of penetrating item, the annular space size, whether that annular space can be 0 point contact or huge, all of it's stated. And then the ratings, F, T, L, and of course, if it had a W rating, it'd say a W on it as well. L meaning air leakage, simulating smoke movement through that assembly. So, key things to know: systems first. If there's no system from any manufacturer at any of the laboratories, let's say Hilti didn't have, just for grins, they probably do have it, but if they didn't have a system that fit the condition in the field, then the 3M system or the STI system, if they had it, should be used. How does that work with submittals and such? The litigious society we live in doesn't care about submittals. It cares about safety. And if a tested, proven system is available, it wants a tested, proven system first. So just remember that when you start thinking about engineering judgments and the why and the how, et cetera, et cetera. Directories are open, public, and free, so use them. Again, system selection, analytical analysis of Firestop systems. Contractor selects. The analytical part of it is done by the Special Inspection Agency or the AHJ, the Authority Having Jurisdiction Code Official. In Chapter 1 of the Building Code, it says the code official is supposed to say that the walls aren't to be closed up before the code official gets a chance to see what's going on with the Firestop systems. And that's another education that constantly takes place, whether it's the FCIA or the manufacturers who are talking to the code officials about what is an acceptable Firestop system. In other words, does the system match what's in the listing that's being shown right now, and has it been installed to the manufacturer's installation instructions? I mean, that's the systems analysis. Without the system, the listing from the UL directory that I just showed you, the manufacturer's installation instructions, we have no idea what the heck we're looking at. And these are the questions that need to be asked to analyze, and the same questions that got to be asked to select these systems. That's why we believe that the contractor and the special inspection agency need to have equal knowledge. The part of the Astm E2174 is observation. If you're going to observe how it's installed, you got to know how it's installed. So we believe that both are needed. Let's get moving. We haven't seen it shown installation of Firestop. It's a really old slide, but you know what? It's very good at showing the action of Firestopping. The Firestopping is an action. It's a verb. It's not a noun, because it doesn't become a system until the action takes place. It's not just a product being put in the head of wall, in the fluted decks, around the penetrating items. It's not that. Also know that fire dampers are tested to something else, UL 555, 555S. We've got another webinar coming on fire dampers, so you can learn about it from the people that know fire dampers. But just know that fire stopping is used around it. It's got to be part of the system, tested to the UL 555 or the 555S for smoke. And the authority having jurisdiction and the manufacturer of the damper should be saying yes or no that can be used. Know that there's tons of Firestop products in the marketplace. Read the manual of practice. That's where you'll learn about them. There's tons of systems, but really what has to happen is that the materials, the systems, the installation instructions, the life safety drawings all need to wind up in this person's hands with the proper tools, safety equipment, PPE, in order to get this stuff installed properly. Then after they're all installed, it has to be invoiced to the general contractor and of course the money collected. So there's a lot of cycling, a lot of things that have to happen before we can call something a Firestop system. How's it installed? Who installs this stuff? Stuff meaning the technical term for fire stopping. 3 ways. Each trade, he or she who pokes a hole fills it, or there's a specialist contractor or a combination thereof. We think that the FM 4991 UL qualified, ULC qualified, FCIA member, best qualified to do that kind of work. What happens when it's wrong? You get a circus. That's what you get when you see the people on the left. You know, you'd think that after 40 years of education about this industry that we'd have it right by now. But because the products are marketed to anybody without restriction, guess what? It can get in the hands of the wrong people. And we think that's not a good thing. Without a good Firestop contractor that understands what the heck's going on, an inspection agency, a qualified Firestop contractor, approved Firestop contractor, a good manufacturer that believes in testing their products to what can be expected in the field, it's a mess and has been for a lot of years. Just know that this is an important part of fire resistance. So important that we worked with some not so small companies to build contractor qualification programs to qualify the companies that install this product to become a Firestop system. FM approvals, UL. I mean, UL is a $2 billion organization. FM, they're right with them, huge insurance company, multi-billion-dollar organizations. And they felt it was important to have these 2 programs for our industry, for fire and life safety. How are the other industries coming? I can tell you the fireproofing industry has jumped into it. They have a qualified SFRM contractor program now. The dampers, the doors, rolling doors, swinging fire doors, the walls themselves, it's changing, but it's going to take a while for us to get there. Buy a contractor qualification so they get it right the first time. That inventory's got to be built. The building owner has got to know that they've got something that's not improperly installed, which is what's in Nfpa 1 because they're responsible. Having an FM and a UL contractor helps know that that product was installed properly to the tested and listed system. How do they get there? Pass the Firestop exam, UL or FM, for each program, write a management system, have an audit by the FM or UL people at the contractor's office and then also at the job site to make sure that the process works. Appoint a company or a person at the company as a DRI and then get listed at FM or approvals, UL, and FCIA.org. What's in this management system? It's really the process that the company uses to get everything done. Get everything done, I'm talking about fire stopping, done in accordance with the tested and listed systems and the manufacturer's instructions, using safety data sheets and all the safety equipment that's needed to install this properly. But if you look at this outline, this is not much different than what the manufacturers go through for their ISO 9000. It's not much different than you would see from the healthcare facility engineer when the Joint Commission comes through for their audits as well. They talk about everything, the facility, the safety, the construction documents. How do you review them before you send the workforce and the materials out to the project site? How do you select systems, analyze them? How do you handle the materials to make sure that they are handled in accordance with the manufacturer's instructions? What about the installation and applications? What about testing and calibrating your tape measures to make sure you measure the angular space so it's just right? What about a non-conforming product, broken pails? How do you isolate them, put them on the side of the job site? How do you maintain your records? What about this master certificate of compliance that's in the specification, been required to provide the building owner and manager with a certificate that renews annually and requires somebody to come look at the barriers so that there's a automatic annual visual inspection that conforms to the International Fire Code's annual visual inspection. What about inspection itself, though, for new construction? These two standards, the backstory for these two standards is that the FCIA founding board actually thought that, how do we separate the contractors from those that have no idea what they're doing? How do we get third-party inspection into the building codes? How do we build a body of knowledge, which became the Firestop Manual of Practice? How do we find ways to have a place where education can take place that's very specific to fire stopping in a very high level? That's what FCIA does, and the ASTM standards are a result of it. Take a look at these pictures that just kind of flew up on the stage. Thank you to Adler Firestopping for providing them. Look, somebody has cut a triangle in that Firestop material, and look where the measurement's taking place. Currently, that's not what the International Firestop Council, the Manufacturers Association, says when inspecting fire stopping. The manufacturers say that the Firestop system sealant measurement thickness measurement shall take place where the bond line, in other words, where the sealant touches the concrete, and in this case also touches the metal penetrating item. Why? Because all sealants will shrink some. Latex sealants will shrink somewhere up to 22% of their original state, meaning if that material is put in flush in a block like is shown on the UL or FM design, that there's going to wind up being a shrinkage in the middle in a concave shape, meaning that if you measure in the middle, you're going to come up short of the thickness that was specified in the system, and then possible rejection to the contractor, which is an incorrect judgment according to the International Firestop Council. It doesn't say that the standard does ASTM E814 2393 do not say where to measure the thickness of the Firestop sealant. The standard is silent on that, and for a good reason, because it's the manufacturer that should be telling the inspection agency, where do you measure the thickness? What's the acceptable thickness that should come? System tells us that, obviously, but the manufacturer should tell us what the shrinkage is, and let the manufacturer who knows the chemistry of these products cover that piece of it. So measure at the bond lines always, for whether it's a joint system, head of wall, bottom of wall, perimeter fire containment. Measure at the bond lines, unless of course you can't do that because it's overlapping onto something. Then if you think about it, the spray materials has a minimum and a maximum, a shrunk value, if you will, stated in the system, and a wet value. We don't have that with sealants. That's why we say stick with the manufacturers about that. How does inspection take place currently? The ASTM 2174-2393 are mandated for buildings 75 feet and higher above lowest fire department access, and in category 3 and 4 buildings in table 1604.5, that's the structural section of the International Building Code. What about the other buildings that aren't that tall? Some of them get caught in that table 1604.5, but not all of them do. So that's why you see other methods take place. What's interesting is, I can tell you that our specifier friends are specifying independent inspection all the time in their specifications. They don't differentiate between a high-rise building and other buildings. It's in there all the time. Does it get bought by the building owner all the time? Not necessarily. When it doesn't get bought, what kind of inspection takes place? Then it's a free-for-all, basically. Can the contractor do their own? Sure. And could the general contractor rely on the contractor's statement? They could. What about manufacturers? We find that they don't inspect. They might come survey, look around, state that it seems to meet the system and criteria, but they really push it to the third-party independent inspection agencies to do that kind of work. Is it in other scopes of work? Not currently, unless, of course, Chapter 17 of the Building Code is actually quite broad. You know, the building code official could say to the specifier, to the design professional, I want special inspection for all fire resistance, period. For instance, fire dampers state that there be commissioning done, such that there's commissioning at the start, when the building is commissioned to start with, 1 year afterwards, and then it's tested every 4 years in everything but hospitals. Hospitals are 6 years. So a little different thing there. But that's part of the Nfpa 80. Fire doors are only inspected annually to make sure they close and latch, no bolts are missing, et cetera, et cetera, et cetera. You find that also, the directions and how you do that in Nfpa 80, rolling doors as well. Fire rate glazing, you know, what's to inspect there? The big thing is making sure it was installed in accordance with the system in the first place, then it just stays there. People don't typically put holes through glass to put piping and all that kind of thing. So 21742393 we talked about, required by the International Building Code from 2012 onward. I talked about the types of buildings that are required in. Know that Chapter 17 has 2 approvals for the inspection agency and the inspector. That's something that really I don't think gets enforced much. I get that most of the jurisdictions have a procedure for approving the inspectors, but I'm not sure what the procedure is for approving the inspection agencies. Here's what the language says in the definitions. For an approved agency, it's an established and recognized agency, a company, regularly engaged in conducting tests and furnishing inspection services acceptable to the AHJ. That inspector is employed or retained by the agency. The retained means they can be an independent contractor of some kind, but the agency's got to be a company of some kind. Here's the category 3 and 4. Know that it's required. The 3 and 4 type buildings, the category risk 3. Take a look at the types of buildings that get special inspection. It's pretty wide. Elementary school greater than 250, and now we've also got residential greater than 250 that's in the International Building Code 2021 version. The FCIA was the code proponent to put that in because we felt that it was needed for multifamily occupancies. We think that's going to be a big deal when the 2021 code is adopted in many jurisdictions around the country. Other types of buildings are in that risk category 3 and 4 as well. I won't go into the details in that as well. 21742393 says it's independent inspection. The inspector and inspection agency can't be competitors of the contractor, the manufacturer, or the supplier. It can't be the distributor, the manufacturer. That's why the manufacturer shy against it. ISAC 291 is the accreditation criteria for companies that do inspections. It's really a good program. It's not used as much as I'd like to see it in the fire stopping, but I do believe it's growing. It's going to take time for it to take off, just like it took other programs to take off as well. And in some of this section in Chapter 6 or Section 6 of the ASTM 21742393 are going to be changing over the next few years. They're not changed yet, but look for some changes to come in that as well. So the inspector, our opinion, passed the UL or the FM Firestop exam and the IFC exam, International Firestop Council. Those are all 3 great exams. So I'm going to, quickly wrap up with some pretty rotten slides. This is something that a friend of ours, Rob Halati, sent us a long time ago. You're like, really, this kind of stuff still exists? Foam, holes, upside down wrap strips and collars, scab patches. Really? Come on. This is a documentation sport, a tested and listed system sport, and really deserves more respect. And these manufacturers spent millions on testing, yet people buy their products and schmuck it up there like that you see. SCHMUCK is a technical term, and it's just a mess what we see in the field sometimes. Mind you, there's a lot of companies that do it right, get it right, label it. We've got an ASTM standard going on in labeling. We're going to try to put that in the 2027 version, probably the International Building Code. that says how you label the assembly, how far from the assembly should the label be, can it be stuck to the wall, is it supposed to be above the piping that you see in front of you, what's the minimum language that should be on there. There's not much uniformity in that. We're working on that standard now. Jay McGuire, one of our board members, has been passionate about it. We're working together to have that work. But there's some good fire stopping that's taken place over the years. Good contractors, great inspection, all that make sure that fire and life safety works at the end of the day. And we hope that more and more companies get into this in the right way so that they understand what the minimum requirements are for fire stop inspection agencies, for special inspection, that pre-job meetings are important, that the test and listed systems are important, that somebody's going to be watching them at the pre-construction meeting. They're going to inspect it such that they're looking at 10% of the observation of each type of penetration fire stop, no less than 1 per 10,000 square foot of floor area. And what's that type of fire stop? It's by system, by contractor, to make sure that every contractor gets inspected the same as the other contractor that's there. The electrician and the plumber should have the same percentage of theirs looked at as the fire stop contractor, so that nobody gets missed. Destructive testing seems to be the way that things are going now. 2% of each type of penetrating item, no less than 1, no less per 10,000 square feet of floor area, and then the Astm E2307, 1 for every 500 lineal feet, 152 lineal meters of joint area as well. Labels, we talked about that. Standard is coming. FCIA is working on it. We'll be at ASTM in October to see if we can get things moving along just fine. One thing that you should know from a contracting perspective and a building owner manager perspective is that your inspector and your contractor company, the inspection company and the contractor company, are communicating with each other. If they don't communicate, and it's a fast track project where maybe the contractor loaded the project up with 60, 70 people installing fire stopping, and they're getting 1 floor done every 2.5 hours. You know, if that fire stop inspector finds a bad process resulting in errors and doesn't communicate it for 3 days, A, they've wasted time, which delays the opening of the building, and B, that fire stop contractor spent a lot of money for nothing. And the building owner spent a lot of money for nothing with that inspector because the communication didn't take place. The building code says that immediate notification is supposed to take place from the inspector to the contractor. Like, woo, immediate. That's now. So make sure that communication process is set up. Know that there's extra inspection if somebody messes up. The inspector shall not supervise the contractors or direct the fire stop contractor. That includes, in our opinion, FCIA's opinion, system selection. The inspector's hired to verify the contractor knows what the heck they're doing, not to supervise them and tell them what systems to be using. That's not the role of the inspection agency. The inspection agency's role is inspect to the inspection documents. Keep that in mind as things move along. Calibration, we talked about. Tapes, measuring tapes need to be calibrated. The evaluation has to be done based on the manufacturer's installation instructions, and then the repairs also have to be done to the manufacturer's installation instructions. We've noticed the last 3 years or so that the manufacturers are starting to put repair instructions on their product data sheets, and thank you to the manufacturers for doing that. It's a big deal, and it's very important because life cycle of the building, this material has to be in it. It has to be a fire stop system and live for the life cycle of the building. So reports are given, and then repairs and patching is done through the life cycle. This concludes right at the end, right at 11:30, basically when we told you we'd be doing this. Finishes up what we want to talk about on barrier management codes, standards, and the FCIA, as well as the programs. Proper design, installation, inspection, and maintaining protection is something the FCIA has had in its mission for the last 23 years. Proper design, installation, inspection, and maintaining protection. Something to keep in your head and know that the FCIA has driven the standards to build that. We respect our manufacturers who were there before us, building the test standards that Asdm E814, UL 1479, UL 2079, that showed up before we existed as an association. And we appreciate the opportunity to participate in the standards development process to make sure that the products that are tested reflect what's actually going to happen in the real world. And we've been doing our best to try to input those perspectives to that standards development process. Then find ways to build installation standards for the contractors, the FM 4991 UL Qualified Contractor Program, to find ways to quantify the value of those companies. And then inspection, independent inspection, quantify the value of those companies and the individual inspectors through education, the manual of practice, and the exams, FMUL and IFC. And then also find ways to provide our FCIA members a way to get into the barrier management services. Why are they best qualified? You know, the nits and gnats of fire stopping, the intricate detail, is not something that all the different construction disciplines know or embrace. The Firestop contractor does, and that's what puts them in the position, we believe, to service all the fire resistance to make sure it's maintaining its protection for the life cycle of the building. That's what we got to do. Why? Because what's left in buildings, when I say what's left, I'm saying what fire resistance is left. Because when the 2000 building code came in, the 2006 building code came in, a lot of the compartmentation went away. Horizontal assemblies became really important. Vertical assemblies, smoke barriers and fire barriers that are left have to work because there aren't many of them anymore to stop spread of fire or slow the spread of smoke in buildings, both of which are lethal, both of which cause property damage. I hope that showing you the fire codes, if you're a healthcare facility director, a building owner and manager, we hope that you can use that with your finance people to say to them, look, it's the law. The fire code's been adopted locally. It says we got to do an annual visual inspection of this. We've got to hire people to do it, or we're going to subcontract it out. Whatever it is, it's something that has to be done. And FPA 1 says every 3 years. Whatever your jurisdiction is, that's what's got to be in your procedures to get that done. Use those slides to talk to your finance people about building a budget, line item budget for your fire resistance in buildings. To our contractor friends, that's the story to tell to your building owner friends. You don't want them to be on this stand trying to defend loss of life or big loss of property as a facility professional. You want to protect your friends. Your friend's the facility director, your friend's the building owner and manager. I had a friend at the Association of Physical Plant Administrators, APPA, a university guy. He came up to me after I gave that presentation, the exact same one you just saw. And he said, Bill, we're going to do this. And the reason why is because I want to sit in row 2 of the courtroom and not on the stand. So if we leave with you anything, that's what we want to leave you with. Install it right in the first place. Get the testing right. Don't mess around with the engineering judgments. If you got a system, use the system first. Make sure your crews and the staff know how to install it properly. Make sure the inspection agencies don't let stuff go. And then at the end of the day, work to maintain the protection just like it was installed in the first place. So at this point, I see there's some questions that came up, and you know, I didn't see a lot of them come up, but let's go ahead and start answering them. So Rich, if you want to turn on your microphone and camera there, then we can kind of tag team this and off we'll go. So okay. If it goes the way it normally goes, you know, the questions will start coming in once we stop talking and let the questions start going. So the first one is, why is an L rating an L and not a S? Or, you know, you get the LW, you got the W rating for water, you got the F for fire, you got the T for temperature, we got an L for smoke. Really? Any idea there, Rich?
Oh yes, I'm very well aware of that. That was probably my decision back when I was working for UL. When we started working on the methodology for smoke leakage, it was in, you know, direct result of some provisions in the Nfpa 101 Life Safety Code about passages of smoke. And we thought if we used the S for smoke in that rating terminology, that it would bring up questions on the code front when we went for code adoption of the requirements of what is in the smoke, how many parts per million, how toxic is it, all sorts of questions that none of us are prepared to answer. So we thought by using the phrase air leakage, we could avoid those sort of questions. Well, that didn't turn out to be the case. Still took about 13 years from publication of the requirements in the standard till the 2006 IBC, which first adopted requirements which limited the passage of smoke on a quantifiable basis. But anyway, so it was an attempt to, I guess, avoid those sort of questions and get quicker code adoption, but it was a futile effort in the end.
Understood.
But just think of the leakage in reality meaning smoke.
Air leakage simulating smoke. Good idea. Other questions? I'll mention Rich and I have been doing a series on the ancillary standards that are over at ASTM. Exposure, movement, et cetera, et cetera. I mean, that movement standard, relatively new. I mean, that's 2008 is when the FCIA wrote a letter to the International Firestop Council and said, hey, look, the penetratum items are going to move because they're hanging from a ceiling above that might have, you know, carts moving over the top of it for hospitals, file cabinets and office buildings. You know, we're going to get some movement here. We don't want something to measure the movement of somebody jumping up and down on the pipe while they're putting sealant on at the fire barrier. We want something that's reasonable, that catches water hammer and the light movement that might be expected. I mean, that's where that came up. And frankly, you know, 2008 is when we wrote the first letter. We had discussions at ASTM with our manufacturer partners, and it really isn't showing up in the general public, if you will. I saw some of the manufacturers have started webinars, as has the FCIA. We did one, Rich did one for us early in the year. You know, that didn't show up really until probably a year ago or so. So, you know, as Rich said, by the time the L rating was developed, before it got into the code was 12, 13 years. You know, the code development standards developed from the time you say, when I say you, I'm saying the audience, the contractors, the inspectors, and you know, architects and building owners. You say, how come you guys don't do this? Well, okay, fine, we'll form a committee and get it started. It can take 10 years to come up with the solution, sometimes more. The exposure piece is another one. You know, Rich mentioned that the exposure is something, you know, under that one slide that talked about chemical resistance. You know, the manufacturers have started an exposure standard at ASTM as part of the questions in 2008 that we asked our manufacturer partners. They're very receptive to working together to come up with standards to develop that are ancillary to ASTM E814 and come up with those standards that cover exposures. Right now, we've just got a couple of exposures. We don't have all of them, you know, oils, hydraulic oils, and all that kind of stuff. But as Rich said, you get that from the manufacturer. Have that conversation with their industrial hygienist to see if that stuff actually affects it. Next question we had come up is, can I get a copy of the slides to use to advocate for better management of our ferry barriers? So our answer is absolutely. We post the slides to FCIA.org in the webinar section publicly, the slides. The recordings we save for the members only. But the slides are open and public for you to go grab. So that's a great question from a building owner or manager saying, hey, I want to use this to justify to the finance people that we want to have an annual visual inspection, triennial, whatever policy that they want to do. That's great to hear. Looking at other questions, somebody hit me at 11:31, 2 minutes before I finished, and said, time's up, Bill, come on. Always glad to see we got humor in the audience. Thank you. So questions out to the audience on fire stopping, fire resistance. Questions out to the audience, going once. Questions going twice. Might ask here one question. Oh, here's one. Are there any fire stops evaluated to the UL 1709? That'd be the jet fuel stuff?
Yeah, correct. 1709 is the hydrocarbon fire exposure typically associated with petrochemical facilities. And the short answer is no, there are no fire stop systems evaluated to that time temperature curve. We talked about the time temperature curve used for 1479 as reaching 1,000 degrees Fahrenheit in 5 minutes, 1,700 degrees in 1 hour, and 2,000 degrees in 4-hour time period with the hydrocarbon curve reached 2,000 degrees Fahrenheit in 5 minutes. So it's a very rapid rise temperature exposure, but the answer is no. There are no systems evaluating that time temperature curve at this point in time.
Now that the time temperature curve goes from 0 to 2,000 degrees right now?
Yes, 0 to 2,000 right now.
And then are the ovens able to do that, the furnaces at the various test laboratories?
With some modifications, the answer is yes.
Okay, so if one of the manufacturers wanted to get creative,
I'm sorry, go ahead.
so if they wanted to get creative, they could. It just costs money.
There you go, exactly.
Modifying a furnace, cost of a new BMW maybe?
Well, in terms of testing columns, the UL 1709, no, it's not anywhere near that expensive. It's just some lining of the furnace and some changes of the burners, which are relatively easy to do, and then the use of heptane flammable liquid to accelerate that temperature ramp up. So it's not a big deal. It's not a costly process to do that.
Okay.
But Firestops UL would have to think about it in terms of how best to modify the system.
Sure. I imagine it's quite an exposure. And, you know, maybe some of the manufacturers have done this and have some, you know, certainly the listings, you find the public listings in the UL directory, the FM directory, et cetera, et cetera. But, you know, some of these manufacturers have fire test laboratories and they might not have had UL witness what went on. They might have some data. Maybe they had some fun one day, modified their furnace and ramped it up to 2,000 degrees right now and left it going for 30 minutes and to see what their Firestop system did. You know, some of the manufacturers might have some private test data that they ran somewhere somehow. We don't know. So we really have to ask the manufacturer to figure that out. So looking up, I don't see any further questions. I'll ask the question again. Questions going once. Questions going twice. And one of the reasons why we don't have many questions is that this particular session, we try to do about 2 times a year. The reason is there's always new people that come into our industry and need to get this basic 101 type stuff done. This is similar to what Rich and I did for the level 1 education at the FCIA Certificate of Achievement. And if you do that, there's a good exam. Pass the exam, you get a certificate from the FCIA that you can use to prove knowledge. You know, our purpose for this is to really cover a broad range of topics very quickly. The level 2 is going to cover very specific materials in a very deep discussion and also cover systems. So get ready for that one when it shows up here shortly. So looking up, I'm not seeing any further questions. Rich, any further comments before we wrap up?
Yeah, my only closing comment would be is thank everyone for joining us here today. Hopefully you've learned something, and if you do have any questions, you can certainly reach out to us. We'd be happy to answer whatever questions you think of after the fact.
Cool stuff. Thanks, Rich. And I guess I'll remind everyone, FCIA members, we got a conference in San Diego, November 2 to 5. We are going to offer that hybrid because I know our Canadian friends might not be able to travel in October or November, I should say, or people from other parts of the world might not be traveled because of the virus that's still going on. So know that conference is coming. Know that the FCIA education program, the certificate program exists. You can get a certificate from the FCIA that you can use to prove your competency. Level 1's available now. It's a couple hours worth of education, about 2.5, and then an exam afterwards. Get yourself a good, strong certificate for that. For the webinars, we want to use those as our general education, and really appreciate everyone being part of the program and being with us. Thanks again, Rich, for taking some time to be with us. Thanks to every one of you for being with us on the webinar as well. Thanks, everyone. Have a great week, and we'll see you next time.